Question 17. So we've got a diagram here. We're asked several questions. Compute tangent. Now, one way to address tangent, we could get the angle theta, take the tangent of the angle, but they're asking us in a different order. So we'll go ahead. Tangent is always going to be the y-coordinate divided by the x-coordinate. And remember, because tangent is sine over cosine, doesn't matter what the radius would cancel out. You'd get 5 divided by 5. So we could just say the tangent of theta will be the y-coordinate. Kind of think of slope, y over the x, right? That's what tangent is, negative 4.33. So let's go ahead and we can see that's going to be positive. We're in the third quadrant, 2.5, so we don't even have to put the negatives in there. Just say that's going to be positive, negative divided by negative. We do this and we get that to 3 decimal places is equal to 0.577. Okay. Now we're asked to determine the value of the angle theta in radians. So since we know that we now know the tangent, we could use the tangent of theta. We could also use cosine or sine and do an inverse. But since they had us find tangent, what we know is tangent theta is equal to 0.577. So that we know if we take the inverse tangent, that the inverse tangent 0.577 will give us the theta. But it's, again, remember, tangent, when we take an inverse tangent, it's going to give us an angle between pi over 2 and minus pi over 2. So going this way and going this way. So once we have our answer, it's going, it gives us an answer in either the first quadrant or the fourth quadrant, but the fourth quadrant one would be a negative angle measured that way. So then we're going to have to figure out what we're actually going to end up with. So what would be this reference angle? What we're going to end up with is, notice this, you put the ray kind of coming here. This angle will be equal to this angle. So once we're done, whatever the answer we're going to get will be positive because it's in the it'll be the first quadrant angle, and then what we're going to have to do is we're going to have to add pi, right? So whatever we get, we have to add pi to it to actually get the angle of theta to make it make sense. So let's do this, and it maybe will make more sense as we go forward. So tangent, not tangent, inverse tangent. Let's just clear this out. Inverse tangent of 0.577. So what it's doing is it's really 0.577 in the first quadrant, right? Because it would be the same thing. Gives us radians, gives us 0.523, which is about half a radian. This is not the correct answer yet. That would be the angle in the first quadrant. And then what we need to do now to get it is we need to take this answer plus pi. Okay, so theta, and over here we'll just add pi plus pi. So that's going to be 3.664. 5, rounding to 3 decimal places. 0.665 radians, which matches our answer. But that's how you get it. You plug it in. You don't get that answer directly from your calculator. You have to realize uh, inverse tangent's only going to give us a number somewhere between negative pi over 2 to pi over 2. And then we have to make that adjustment. Write the coordinates of another point on the circle that would lie on the terminal side of an angle with the same sine value as the angle given in the picture. Okay, so this picture, what else would have a negative sine of 2.50? Well, that would have to be in the fourth quadrant, right? That would have to be over here. This will have the same y value. Drawing's not quite so good. And what would the x value be? Well, it would be positive 4 point. It's just how, because it's positive 4.33. Right, the coordinates of another point on the circle that would lie on the terminal side of the angle. Okay, yeah. So you kind of go around that way. So x is going to become positive. It's over here. And the y coordinate would be negative 2.50. See how that works? Now we're asked to write the coordinates of another point of the circle that would lie on the terminal side of an angle with the same cosine value as the angle given in the picture. So same cosine means that the cosine would have to still give us this value here. So we could come basically straight up so that we maintain this x coordinate. But now that we're in the second quadrant, what's the y coordinate going to be? It would be positive 2.5. Now, they didn't ask us for the angle, which is nice. We could find it if we had to, but they're just asking us for the coordinates. It's going to be positive 2.50. Okay. So the x coordinate is going to stay the same, but to get that, we had to go to the second quadrant. So our y coordinate changes to 2.50. Write the coordinates of another point of the circle that would lie on the terminal side of an angle with the same tangent value as the angle given. So we kind of figured that out already, actually, right? We're over here. This is when we did our B part. That's the angle we ended up with. Of course, they're not asking for the angle, they're asking for the coordinates. So what would the coordinates be? They will be the same x and y values, but they will both be positive. Up a little bit, positive 4.33, positive 2.50. So we kind of see once we have a given x and y coordinate, that's really giving us the sines and the cosines as we go around. So we get 4 angles out of it. That's number 17.